Hello students, welcome back to Turning Point classes. In this session, I discuss first level questions from the chapter Moving Charges and Magnetism, that is the fourth chapter of second BA physics. Let us start. The first question is if the distance between two current carrying straight wires is doubled, the force between them becomes. Four options are given. Just you might have learned by this time the force between two straight parallel conductors of infinite length separated by distance d when placed in air. So F is equal to mu naught I1 I2 divided by 2 pi d. Even if they are of finite length, the force between two straight conductors is inversely proportional to distance. If distance is doubled, automatically the force becomes half of that. So simple question, d tends to 2d, this implies F tends to F by 2, force becomes 1 by 2. So B is answer for this question. The second one is a circular coil of 14 turns carries a current of 1.6 ampere, thereby generating a magnetic field of 3 into 10 power minus 5 Tesla at its center. Radius of the coil. Simple problem. Just recall the formula what we have. Magnetic field at the center of a loop. Formula is known to us. B is equal to mu naught I by 2r. If there are n number of turns, same formula, when you multiply by n, you get the magnetic field at the center of a coil having n number of turns. So if I multiply n number of turns, that gives us the magnetic field at the center of a coil of n number of turns. Just we have to find what is the radius. Just radius is required. So B is given as 3 into 10 power minus 5. N number of turns, that is given as 14. Mu naught. Mu naught is 4 pi into 10 power minus 7. 4 pi. Pi I write it here itself. 22 by 7 into 10 power minus 7 into, this is 4 pi. I current is given as 1.6 divided by 2r. 2 into r we have to find out. Just 7, 2 times 2 cancels. Then rest of things simplify r. So we have 4 into 22 into 1.6 on the right hand side. So 3 goes to denominator. 10 power minus 5, here 10 power minus 7. So if we simplify, right hand side we have 10 power minus 2. This I will take it as 0.5 times approximately. So 3 into 5 is 15. So I take a 0.5 into 3 is 1.5. 1.6 is given, make it as 0.5 approximately. So R is approximately 0.5 into 4 is nothing but 2. 2 into 22, 44. 44 into 10 power minus 2 meter. So among the given options, that is option B. So this is 44 centimeters. 44 centimeters. This is approximately 44 centimeter. So we'll go for this one. Actual calculations, we are not supposed to do it. So approximate calculations, taking nearest integer. That is the way we have to go forward in CET calculations. Come back to the next question. A current of 1 ampere flows through a conductor of length 5 cm bent into an arc of circle of 1 cm radius. The magnetic field at its center is, make use of Biot-Savart's law because it is not a loop. So just use Biot-Savart's law. Magnetic field. Magnetic field dB is equal to mu naught by 4 pi I delta L sin theta by r square. Theta is equal to 90. So therefore you drop it. So I delta L, mu naught is nothing but 4 pi into 10 power minus 7. 4 pi cancels, you get 10 power minus 7 here. I current is given as 1 ampere. Delta L is the length of the element, that is nothing but 5 into 10 power minus 2. It is given in centimeters, converted into meters. Now we have r square. R is nothing but radius, that is 1 centimeter. 1 into 10 power minus 2 whole square. So if you simplify, so you have 5, here 10 power minus 4, Here 10 power minus 7. So if we cancel, we will have 10 power minus 3, minus 3, minus 2. It is 10 power minus 5. That's the 5 into 10 power minus 5 is it is there in option B. So B is answer for this one. The next question is if a proton and an alpha particle enters a magnetic field perpendicularly, then the ratio of their radii is, just recall the basic equation, F is equal to QVB, that is equal to MV square by R. So if I recall this, remember it is fine, otherwise QVB magnetic force, that is equal to MV square by R. Simplify this. So when V gets cancelled, I want R. R is equal to MV by QB. So radius, if you recall, MV by QB, so you can save a few seconds. So R is equal to MV by QB is the equation. So if you observe the two given particles, one is a proton, another one is alpha particle, only mass and charge are varying. V and B, nothing is given, therefore you have to take them as constants. So R proportional to M by Q. Radius described by proton divided by radius described by alpha particle. That is what we have to calculate. M by Q, proton 1, mass number is 1, charge is also 1. For alpha particle, mass number is 4, charge is 2. So just RP, M is nothing but 1, mass number is 1, divided by, for alpha particle, mass number is 4, divided by 1. So if you simplify it, you will get 1 by 2. So you will get option A is answer for this question. Fifth one, an electric field of 1500 volt per meter and a magnetic field of 0.4 Tesla acts on a moving electron to produce no force. What is the electron speed? No force means magnetic force must be equal to electrostatic force or electric force. So magnetic force, electric force, both are equal. Just equate them. F is equal to QE, that is equal to magnetic force if I take it QVB. Simplify. QQ cancels. V is equal to E by B. Electric field in the problem is given as 1500 divided by is 0.4. Just you can write it as 15,000 divided by 4. That is nothing but 15,000, 16,000 if we take it around 4,000 I will get it. So that is nothing but 3750 is the answer for this one. So option C is answer for this question. Sixth one, a charge Q is at rest in a magnetic field B. The force acting on it, just take all the formula, F is equal to QVB, V is equal to 0. So therefore, no force acts. So F is equal to QVB sin theta is there. So F is equal to QVB. If I take V is equal to 0, then F becomes 0. So no force acts on a charged particle which is at rest in a magnetic field. D is answer. So with this, I end this session. I will come back to next session with a few more questions. So if you have not watched the videos which I uploaded earlier, link is provided. Go to that link and view previous videos. So if you are not subscribed to Turning Point Classes, subscribe to Turning Point Classes, share the link with your friends and like the video. Come back to next class.